Okay, hello everyone, I'm Lucas. So I think now we are arriving at the second part of AASL. So I think now we're going to the section B question. So let's see. So just now in section A, I think I've used like 20 minutes, right? So I've explained the question and like do the question at the same time. So probably if you with enough practice, I think you guys can like finish it like a bit even quicker than me. So let's see, question. I think it's a stat question here. So about the company performance in the current year. Last year they gave a total of 60 performance, in which the maximum capacity would be 800. The number of tickets sold N is displayed in the frequency table below. Find the value of P. Okay, so since they told us that there's a total of 60 of shows, right? So I think the whole thing here should be 60 in general. So I think in order to find P, we just need to subtract everything. Okay, just like this. So doing slowly. So there's like 30 minus what, 21, right? So I think that's actually just 9. So 30, yeah, right? Write down the modal class. So again, modal class is just a fancy way of writing the word mode. So look at like the most frequent one. So this is actually 9. So I think the modal class is this part here. So again, we don't write 30. Okay, 30 is wrong. Don't write 30. Remember, write the context of the question, which is here 600. Smaller than, and then smaller than 800. Okay, don't write 30 as your answer. Write down like the context of the question. Okay, so remember this one here. Okay, so 2 marks, easy 2 marks. Cumulative frequency curve of these data below. So okay, so median of the ticket sold. So median is like the middle, right? So one thing of like cumulative frequency curve, actually they already help you to write down in ascending order. Okay, ascending order already. So you don't need to like order them first. So 60 will be my maximum frequency. So I divide that by 2, I get 30. So 30 is just across, which is somewhere right here, right? So strike down, I think that's like 600. The number of performance were at least 80% of tickets were sold. So at least 80%. So I think 80%, right? So let's find how many of them was 80% of 800 first. Okay, so I think like 640, right? Is it? Okay, so how many do it? Actually, the whole question comes down to how many performers that sold at least 640 tickets. So we look at here. So this is like 620, 640, right? So I think we're looking somewhere around here, probably here. And then let's look how many of those actually sold more than 640. So we're looking like the higher part, which is here. Okay. So if we want at least, which they wrote here, so we want to look at like the top part. Okay. So if they wrote something that is less, we look at like the bottom part. So this is here is the top part. So I think like 40 to 60, which is simply just 20, right? So just write down some steps. So 60 minus 40, which is 20. Okay, I think that's basically it. 4 marks. I hope this is correct. After performance, the company decided to conduct a survey to obtain feedback from the audience. Say one disadvantage of the company surveying only the first 5% of the audience as they leave the theater. Interesting. I can think of 2 ways, probably. One of them is like, I think, let me think. So 5%, the one way I'll argue is that 5%, probably the sample size is too small, right? So our variance sample size is too small, okay? So to represent the rest of like 95%. So this is one of them. Okay, probably another one, I don't know, probably a little more creative. So I don't know, probably like the 5% that leaves early are the ones that doesn't like the show, right? The performance. I'm not sure about this one actually. So, if we're just interviewing the first 5%, right? I think it's logical to actually, say those people are probably like doesn't really like the show, so they want to like escape the performance earlier, right? Okay, so this I'll just put a question mark here. So if I'm a student, I'll just write this. Okay. So, describe briefly how a company uses collect feedback from using a systematic sampling method. So systematic sampling method is the, probably you have a quota. So basically, I will interview every 5 people that exit the hall, something like this, right? So the company could set up a counter and probably, I don't know, counter and interview people. So a counter that interview people such that, so often just give them example because sometimes like these words are not really clear. So the company can interview a person once every 5 people left the hall. Something like that. So I hope you understand. So every 5 people left, I will interview one of them. Okay, so excuse my like English explanation here. Probably the wording is not too good, so I'll change that a bit. So state the sampling method that could be used for a survey to represent the number to number out here in this instance. So in IB we have, I think is it 4 or 3 types of sampling method, right? One of them is like random. One of them is systematic. One of them is like what, convenience, right? Convenience. And one of them is stratify. So stratify is actually the one that we're going to use here. So we'll be more consistent in terms of like the representation of the demographic background, something like this. So I can set up a interview that I want to interview 10 children and 10 adults and 10 elderly, something like this. Okay? So stratify is the one to go. So last year, 36,000 tickets were sold in Nutcracker. Okay, Boston Whisker show amount spent on audience souvenir shop. So this is another question now. Okay, estimate number who spent $3.25. So what? $3 here, right? To 25, which is the max. So remember, Boston Whisker, this is the Q1. This is the median. Okay, or Q2, this is Q3. So we want more than the first quota. So how many people, right? So remember, like Q1 is 25%. Okay, and then if we want more than that, then so here is 25%. So I think the rest of them is 75%. Okay, so 75%. So 35% times what, 36,000, right? So so which is simply just times 75. Okay, and then we compute this. So 360 times 75. So what the hell is that? Double check. Yeah, right. 0, 0, 3, and then 15 plus 3, 18. So 0, 0, 0, and I add up 1 here. 7, 2. Okay, so I think there must be a faster way. So I hate this. Okay, 2700, which is small, right? Yeah. Wait, I think I should just divide this by 4 and then times 3. Bruh. Okay. never mind. So the way we actually, for this one, is actually easier. So we can just divide this by 4 to get 25%, and then we times 3. Okay, here. So that's done. So I'll probably just write down no space here. So DII. Half of the audience spend less than A. Find the value of A. So half of the audience, right, spend less than A. So the keyword here is half. So half. Some of these there is like break this up into 50%, 50%. So 50%, 50% simply means this is like the median. Okay, median. So I think there's actually this part here. So which is like 7, right? 5, 6, 7. Yeah, A equals to 7. Okay, so simply the median here. This year, a company will again gives 60 performance and expect to sell 70 additional tickets for each performance. Calculate mean ticket for so of each performance here. So let me see. So last year, this is last year. So altogether it's 36,000. So I think I'm going to divide this by 60 to see how many different tickets first. So cancel the O, and then I just do 36 out of 6, which is 6, and add a 2 back. So 600 tickets for each performance. And then so 17 each additional ticket for each. So I think is it this? Just 617. Okay. State with what effect if this increased ticket sales will have an increase of variance of the number. So variance. Remember, this is like the spreadness of the data. Okay, spreadness of data points of data. So imagine you have a regression line that's something like this, right? You have some data points here, so probably here, something like this, okay? And if I shift up, so I'll increase a fixed amount to every single thing here. Actually, this, if we just look at the red and look at the blue, the spreadness of data actually doesn't change, okay? So the only thing that changed here is the mean, but the variance doesn't change, okay? Because still it looks kind of compact, right? This looks like this, and this looks like that. Basically, it's somewhat identical, so therefore, no effect on the variance. Okay, or standard deviation, same thing. Okay, variance and standard deviation, they're like closely related. Awesome, this is done. Okay, finally some math here. The function f and g are defined by Ln and g divided by this. State the equation of vertical asymptotes for g. So I think they give you here actually. So we can look at this. So Lnx, you should know this by now. Lnx should look something like this. Oh, sorry. So probably something like this. Okay. And x equals to 0 will be the vertical asymptote. So look at here. This is like stretch by scale factor of 2, vertical and downward. And then this is like going down by L and D. So actually it doesn't change like the left motion and like right motion as well. So therefore vertical asymptotes, it's still x equals to 0. Okay. Actually they gave you here x larger than 0 simply means x can never be 0. So x will be our vertical asymptotes here. And x equals 0. Okay, and then the graph f and g intersect 2 points, show that the intersection. Oh no, what the hell, 9 marks. So intersection point easy, make them equal. Okay. So you got Ln 2x minus 9 equals to 2 Lnx minus Lnd. Okay. So I think we just need to combine the Ln to both sides. I mean the right hand side. So I will just do it in one go. So there's an x squared over d. Okay. So I've done two things at the same time. I move the power to the front, and then I combine them using the minus log, which is dividing by each other. And then I'll just e both sides such that Ln is gone. So basically you can just cancel Ln here. Okay. So multiply that to both sides, and I got this. And since it's a show that question, so I know I'm actually right or wrong. Okay, so I will do that at the end. Okay, so let me see. So minus 90, so exactly the same, so this must be correct. So that's basically for part A, B1. CP2. Hence, show that the sign is 0. So intersect 2 points, right? Whenever you see inequality sign suddenly just come out, you know it's something about discriminant. So intersect at 2 distinct points means delta larger than 0 or b squared minus 4ac larger than 0. So we just compute that here. So b squared, so basically it's negative 2d squared minus 4ac larger than 0. So 4d squared minus 9 times 4, I think 36, right? Okay. And then look at that, I think it's almost the same. Divide both sides by 4. Okay, I think I got 9d. Okay, and exactly the thing that they want here. Find a range of possible value of d. So basically they want you to solve it. So remember here, don't cancel the d. Factorize the d out first. If you cancel d here, probably you will miss one answer. Okay, and then what we need to do is first find what we call the critical value. Basically solve this square here. Just assume this is equal, so d equals 0 or d equals to 9, right? And then draw them on a number line. So 9, 0. And since this is actually a happy face curve, so you should know it will look something like this, okay? Correctly. I'll do it again. Okay, something like this. So this part is positive, this part is negative, and this part is positive. And then we want to look at the positive part, okay? The positive part, because it's larger than 0 according to quotient. So we take these two parts here. So therefore d smaller than 0 or d larger than 9. Okay? I don't think you need an or actually. Just put a comma here. I think that's okay. Okay, I think that's basically it. Okay. Easy 9 marks. Part 2. The following diagram shows a part of graph. So they show it to you this time. The graph intersects at PQ. In the case where d is actually equals to 10, find the value of q minus p. And give your answer in form of this. So since d is equal to 10, and if we want to solve the intersection point, actually we can use this. If we solve this equation, because it's like a point of intersection, right? If we able to solve this, we know the intersection point. So d is equal to 10, so we're just plugging 10 inside. X squared minus 2 times 10, which is 20. And then plus 9d. 9d, which is 90, okay? 0, so I'll solve this here. And then I can see there are probably some square roots, so probably we need to use the quadratic formula. Okay, so let's try. Plus or minus b squared minus 4ac. So b squared is simply 400 minus 4 times 1 times 90. And this is 2 in the bottom. So this is 400 minus 360. So I think that's 40, right? Okay, and then I think we need to reduce the square root. So let's try to reduce the square root. So 2, 20, 2, 10, 2, 5. So I think this is actually like 20 plus or minus 2 root 10 or 2. So 10 plus or minus root 10. Okay. So I think we have P and Q actually. So P would be the smaller one because you know here, this is actually like in the left hand side of the x-axis and this is like the right hand side. So P would be smaller. So I think P would be the minus 1. Okay, and then Q would be the plus 1. And then we need to find Q minus P. So remember bracket because you're minusing the whole thing. And then I think this is just 2 root 10. Okay. Yeah. I think that's basically it. Okay. Yeah. Is it final question? Yeah, final question of the day. So I think this is like the level 7 question, I hope. I think that like the hardest question among up to now is like the statistic question here because I'm not sure. Yeah, these are I think I'm not sure. Okay. But I think it's good because like here's like 4 marks. So probably I would lose 1 mark here, I would say. Okay. Yeah. So I'll do the review at the end. So if we graph here, fx equals to this. Show that f prime x equals to this. I think there's like a quotient rule, right? 4 marks. So I'll write it here. So because I think I need more space at the end later. So differentiate it. It's not hard. So if you remember the formula, that'd be okay. So the bottom, copy the bottom, differentiate the top, minus the top, differentiate the bottom. But the bottom actually is a chain rule, so you need to do twice. Do the outside first, and then x squared minus 1, power minus 1, which becomes 2, and then differentiate inside, which is 2x. Okay, and then all over x squared plus 1 power of 6. Okay, bottom square. And then let's look at the equation. So I think it could be cancelled at the end, right? Let's hope so. So let's see. Do we need to actually expand all out? I hope not. Okay, so actually I can observe this is power 4, this is power 6. So probably we can like do some division here. So actually these, and these, the expression in size is exactly the same. So probably we can just reduce it. So I can reduce the whole thing here by subtracting this by 2, which is 1, and then subtract this by 2 as well, which is 4. Okay, so the whole thing becomes 8x squared plus 1 minus 8 times 2 times 3, which is 6. Interesting. So 8 times 3 would be 24. 24 times 2, 48, right? So it's okay if I answer here. So if I'm not wrong, so I will know I'm wrong when I look at the answer at the end. Okay, so let's hope this is correct. So 8x squared plus 8 minus 48x squared over x squared plus 1 power 4. So these x squared could be cancelled out, so therefore 8 minus 40x squared. And then we just factor out 8 on top. So 1 minus 5x squared. X squared plus 1 power 4. It's exactly the same of the question. Same, right? Yeah, same. So this is how you guarantee the 4 marks here. Okay, but I feel like the algebra here probably for SL might be a little bit more challenging. Okay. So the way we do this part, the red arrow part, actually observe the question. This is 4, that is 6. So I think I need to create 4 in the bottom somehow. Find the integration of this. I'll do it on the left hand side. So integrate dx. So I think this is substitution, right? So we let u to be x squared plus 1. So du equals to 2x dx. So dx equals to du over 2x. Okay, and then we substitute inside. So integrate, so 8x u cubed du over 2x. Okay, so the whole concept of substituting is try to cancel the thing on top. This becomes 4 here at the end. So here becomes 4, integrate 1 over u cubed, which basically u of -3 du. And then using the power rule of integration, got this here, and then this like -2 over u squared. So u squared, we remember it's like this, right? We let it out. Okay, and then plus c at the end. Okay, remember plus c. Okay, I hope this is correct. Yeah. Okay, party done. At least I hope we can get the 8 marks out of 13 here already. So such that at the end, if you get this one wrong, the part C wrong, I think you should have a level 7 already here. Consider a function gx defined by x as a real number. The derivative of g is this, and then the region of R enclosed by fg the line x0 and x3, the area is this. Find a pretty possible expression for gx. Okay, by looking at this, actually we know that the derivative of the two functions is actually the same. So in order to find gx, right, I think we need to integrate this. So gx actually it's a integration of g prime x. Okay, so I want to write dx as well. So if we substitute inside, you got f prime x dx, and prime and integration, they're like inverse relationship, so basically kill each other, plus c. So gx actually equals to fx plus a number. So if we look at this using a Manson translation, so this is like going up / down by c units, okay, by c units. This is how I view this question here. So basically the curve, 0 and 3 probably here, right? 3, I don't know. Maybe there is a curve that looks like this. That's exactly the same, but move up a bit. And then they told us that this area here is R. This area here is R, which is 27 over 2. And the another answer that comes to my head would be, if I have a top part, I also have the bottom part as well, right? Okay. This, it's also the area. Okay, so one of them is the gx, that's like this gx, and this is also gx, right? This fx in the middle. So the first case would be gx is taller than fx, then you got the purple area here. And if fx is taller than gx, then you got the red area underneath. So I think we have two cases. So you can write down if gx is larger than fx, so basically it means taller. Okay, we cannot write taller in the real exam. So if gx is larger than fx, then if I want to find the enclosed area, remember it's always integration the top minus the bottom. This given in the integration rule here. So the area, so R, equals to the top minus the bottom dx. And I also give them a balance. Well, I think like 0 and 3, right? Yeah. Okay, and this equals to 27 over 2. 2 or 3, forgot. 2. Okay, so gx, I use the substitution here. So gx actually equals to fx plus c. So fx plus c minus fx dx, 27 over 2, and the balance as well. Okay, so fx and fx are just gone, no more. So basically you're just integrating c. So, but c is also a constant, so you can move it outside integration as well. So 0, 3, 27 over 2. So this becomes integration of 1, so basically x, right? Okay, so I think plug in, so I think it's just 3c, 27 over 2. So c would be 9 over 2. Okay, so this is the case where gx is taller than fx. How about case 2, which is the opposite, smaller? Okay, so r would be equals to, again, top minus the bottom. So top will be fx this time, and then bottom will be gx. And then we will substitute the fx in again. I mean the gx, right? Gx would be, yeah. So substitute gx inside just like before. Minus fx, and then minus c. So remember, distribute the minus inside as well from here, okay? From here, this part. And then this equals to 27 over 2. So again, fx is gone. So basically this time we're integrating minus c. Okay, 0 and 3 dx. Okay, and actually this is like exactly the same from here, so just copy here. So here's 3c, here should be minus 3c. Okay, so c would be negative 9 over 2. So I think I have two answers here. So gx would be fx. So fx, what the hell is fx again? The thing on top, 8x over x squared plus 1 power of 3 plus 9 over 2, or gx goes to 8x over x squared plus 1 q minus now 2. Okay, I think that's basically it. So yeah, I think that's basically it. So any like comment with this paper, I would say that the stat question, I'm not sure about part C. Okay, I'm not sure about part C. I think part C it's okay, right? I hope it's okay. Probably my part 2 here is like the wording is kind of like not good. And part 3, you need to legit like remember all of, like the method here. So it's rare that they actually ask this. And remember like the variance definition as well. But I think section A it's actually pretty simple, I would say. Probably for SL this is actually hard for question 6 to remember this one here. But I think the rest is okay. So I hope I don't have any like silly mistakes in the middle. So 1.5 hours, I think it's very doable. Okay, so I think that's basic end for this video here. So thank you very much.